I'm really curious what is going on, because the funny thing really is that on my end, every diagnostic window I have here, whether it's encoding or the networking thing, it's all fine. I just see that it keeps dropping the connection to the Restream server. I'm really curious what's going on. And the Restream side is just claims that it doesn't receive data. It's like, yeah, no shit. But why? Well, is what it is. All right, so this is Kevin, so the answer is no, probably. That seems also something that we should have a dedicated session for, because it seems decently large.
I mean, it's just, so we have a bunch of methods that are like export subject public key info, which returns a byte array. And then for all of the things that have standard PIM encoding headers, it's add a string version of it that then ends in PIM. So it's a lot of members, but it's like a spanified overload, except it's a stringified overload.
You say stringified, but all I see is spans.
Well, all the smaller ones are returning the string, and then the tries are writing to a char span. So like RSA export RSA private key PIM, and then RSA try export RSA private key PIM.
I see. In that case, let's do that. I assume nobody has any concerns with that.
Begin certificate again. We're saying that's what we'll do out of that export method. So we'll export a certificate in the text format, followed by doing it again and again for every member in the collection. So it's the multi-PIM.
So it is correct to pluralize.
Yeah.
All right. Anybody context on this?
Sure. Marek's recognizing that pretty much every call site for object disposed exception follows one of these 4 patterns, getting a name from somewhere and passing it to the constructor. Frequently it's a call to get type. And he's suggesting that rather than doing that, we could add an overload that takes basically this. So you'd say new object disposed exception this, and the implementation, we'd pick one of these, the top 3 things to standardize on, and it would use that.
Seems very reasonable.
Yeah.
Do we need to pick what to standardize on?
We would have to, because the implementation is going to have to do it. Oh, do you mean like we in this room?
Yeah.
No. Whoever implements it would need to. Which would most likely be a survey of all the call sites we can find and pick the most common.
Yeah, it's diagnostic, right?
As long as it's not the last one.
Yeah, can't do the last one, but it could be one of the first 3.
I assume there's no overload resolution issue with adding object, right? The existing calls to string will still call the string overload.
Those will still bind tighter to string, yeah.
Yeah.
And string doesn't.
String doesn't have a disposed state.
Right. Doesn't.
But what if I'm passing a dynamic string? No, it would change, would it?
That's a good question, Stefan.
Screw those people.
Stop using dynamic.
Exactly.
Yeah. That's the right answer.
For sure.
I'd say it's an interesting question. I don't know if it's a good one. It had a bad premise.
Yeah, I mean, we have this concern anytime we add overloads, right? So we might change what things bind to, but this one seems pretty
Right.
limited.
So with non-extension overloads, user-defined conversions kick in before mapping to object. True, false?
Sorry, say this one more time slowly.
It wouldn't
If you-
map to a constructor.
If you have a custom type
Yep.
and you wrote an implicit conversion to string
Yes.
and you pass that to new object disposed exception, is it still going to run the conversion to string, or is it now going to map to object?
I see what you're asking.
I think it will give you
I
an
think it'll give you an ambiguity.
Yeah, unless the thing is typed as object, in which case
Well-
the implicit conversion wouldn't kick in anyways. So
I think the compiler would say, I see an implicit conversion to both object and string, and I don't know which to choose.
yeah, that's what
I think. I'd have to double check that.
Okay. I mean, no one
So
should be
just-
doing that, but
Oh, I'm sure.
Like, no one
somebody
should
has
be-
been doing that.
be in that situation and they're passing themselves or that thing to object disposed exception. But that's the closest I can think of to where we would break someone. So
Well, now you've piqued my interest.
Should
You know-
should we have a overload that takes type for these scenarios where you have, for example, a disposable struct or other objects? I know it's the cost of boxing isn't really a concern if you're throwing an exception, but most of these come down to what you actually want is the type, so you can get the name of the type.
Not necessarily. I mean, like maybe the instance has state that you care about. Like if something in my system is not disposed, I mean, let's say it's a file, seeing that the instance is a file stream is nowhere near as useful as knowing the file name of that guy.
But then you wouldn't be using this API.
Yeah, because this API is just going to do.
So it will call the string constructor.
That's
that
good. Then
is
no
surprising.
breaking change.
I would have expected either object or ambiguity, not string.
So back to Tanner's question then, should we have an overload that takes type?
Honestly, that's where I thought that the suggestion was going. So it makes sense to me. Because the message you get out of object disposed exception is object name colon space quote the string you give close quote. So if we accept a thing that passes in type, that would basically be that the object one is effectively calling the other overload with object.getType. And it's just being like, yep, the string that we generally expect here is a type. Either we can pull it off your object or you can pass in type of your own name or whatever. So
mean,
I don't think it's unreasonable.
I mean, honestly, like, unless we care about boxing, I would probably just leave the object.
Right. When would you use it?
Maybe you have another type that you want to use instead of the, like, for example, you have an internal type and you want to use the public facing type instead. So let's say you had an internal exception type, or maybe exception's a bad example, but maybe you've got an animal class and then you've got, a hidden tiger class, and you really want to you don't want it to be type of tiger, you want it to be type of animal instead, because you don't want to expose that quote unquote internal type name.
Okay, I can buy that scenario, I guess.
Yeah, I mean, we could say that the alternative is you have to, just do what we were going to do and grab the type object and call whichever one of these we decide on.
Yeah,
But
it doesn't seem like it's a critical scenario, but it seemed like something that was worth asking, considering that that's functionally what the object API we're exposing is going to do. And so if we're already going to functionally have an API that's functionally, get type full name, then maybe we should just have a API that takes type directly and then just full name on that as well. But I'm not hard set on it.
Likewise, I think it would be, especially once we're adding something, that we may as well add.
Looks good to me.
Oh. All right, so then.
So I can talk to this one. This is related to the dependent handle API that we approved and was implemented.
So normally we think of adding items. Makes sense.
The polite version of my feelings are, it's reasonable to match the dependent handle. My feelings on whether or not dependent handle should have been disposable would lose us a G rating on YouTube.
Well, the good, but if this thing is tied to something else, the underlying collection might change. Today we only have an overload that takes an I list, and so people were saying that's not really reasonable. Sometimes all you have is an I read only list. So could we just have an overload that takes an I read only list rather than having to implement I list? The API is reasonable. It just means that the implementation, of course, has to handle both now, because there's no inheritance relationship between I list and I read only list.
Do we not have an overload that takes IEnumerable like most of our collection APIs?
No, because the thing has to index, right? So this doesn't copy. This literally wraps the underlying collection and exposes whatever. So if the list you pass in here changes, the wrapped read only collection reflects that. And so that's why
I see.
But when IEnumerable wouldn't work, right? It has to be something that you can actually index.
I see. I didn't realize that it literally wrapped the underlying list.
Yeah, because that's kind of the.
Because I would have.
Yeah, think of this.
I would
as
have assumed that's problematic.
Well, that's the whole point of this, right? So the idea is that this is so the read-only collection of T is what you give your customers, right? So think of dictionaries, keys, and values collection, right? So your consumers don't.
Because I promise I'm not going to mutate, but that's a different discussion.
Sorry, I just wanted to. Read-only collection already has a constructor that takes iList. That's
Yes.
correct, right?
Yes.
Yes.
So it doesn't. Isn't this ambiguous? By passing something like new list of T.
Yep.
That's a good point. Yeah. And IEnumerable, which it is, right? Or I read only list. The call would be ambiguous.
No,
I think
because
with IEnumerable
list
it would not be ambiguous because iList implements it.
It's
Right.
iList is more specific, so it would be a better binding.
right. It's only when there's two when there's two distinct interfaces that don't inherit from each other. That is, if this enumerable is a list or a read-only list, then wrap, because then you can just cast to list or read-only list. But otherwise, copy, which is what the user would have had to have done anyways.
Right. So, like, to me, it's just one of those, you look and you see new read-only collection of X, and now you can't reason about whether it's passed. Then now that is I'm a reference back to the original collection.
Yeah.
And if it was from a link expression or any other IEnumerable, then now it's not, and that's a very different behavior for what looks like the same line of code.
Well, not necessarily, because most of the link expression types.
No. And I agree that it would be unfortunate, but
The alternative is just to have a static create API.
yeah, I think that's the only other option, is just having different API. I mean, all we just say you have to like cast, but that will literally break everybody in the world today. Because literally everything that you could pass in here will implement iList and I read only.
Have to coalesce. Well, it can't coalesce because there's no unifying implementation behind them. It'll have to make each thing right now that's just a forwarder be a, if this one's null, call the other one forwarder.
I think
Which isn't terrible. It's just
the only other option we would have is we could handle the common case and just add overloads for concrete types to just be tiebreakers for overload resolution. And just say if you have something super custom, yeah, you may have to insert a cast.
So actually, there's a question here. How can we add this without copying? Because internally, read-only collection wraps an iList. There is no common type between them, like Jeremy just pointed out. So therefore, we'd have to type this as object and do checks for is this a list or read-only list every time, which seems bad because that's not going to be free.
You'd only have to do it in the indexer. Or you don't have to do it in some of them. Like some of the methods I think will come from a common interface eventually.
Only things that are enumerable or collection, I think.
Okay, never mind. So get enumerator is the only one that you can unify.
Yeah.
Right, because read-only list implements read-only collection, and list does not implement
Interface dispatch.
Right, but checking interface dispatch is not necessarily as expensive as walking the list of interfaces that a type implements to determine is it implementing one of these interface types.
You could also just have two fields.
Yeah, like so. Yeah, I mean that's all it would be is two fields, and everything right now that says call list dot whatever would say if list is null, call read only list dot whatever. Otherwise, call list dot whatever.
That's going. If this is used in any kind of hot loop or anything else, that's going to be additional check every loop, and it's going to show up in our perf traces.
No, it will. I mean, like it's just that these collections are not super lightweight to begin with. Like, you know, they're all virtual, right? Every single method you can call is virtual. You can derive from them, right? They are more heavyweight than list of T or dictionary, right? So they're not super optimized for perf already. That's why I don't care too much, I guess.
It doesn't look like most of these are virtual.
Yeah,
the call to the underlying iList
has no virtuals. But...
Right, the call of the underlying, but the actual methods themselves are not.
Maybe I confused this with collection of T.
From the looks of it.
Because I mean that's mutating.
But then if you're using the read-only collection as in read-only list or whatever, you're doing it twice. I mean, I don't think this like read-only collection instead of read-only list is like the exchange type or.
No, so the problem is we have two kinds of types. We have we have IEnumerable, iList, iCollection, and those were designed on day one to have a mode called read-only, right? So there's a read-only property, and if that's returning true, then if you call any mutation APIs, it would, right? But if your code only accepts an interface, you say you get an iRead-only list of T from somebody, well, it's not guaranteed that this also implements iList, right? And so that's kind of why, these are the kind of seams you see now, where read-only collection of T wants an iList. Well, you don't have one. You only have an iRead-only list, right? And so that's kind of the problem.
So you want to implement iList anyways. The ecosystem's probably wrong, and we should implement and check for all those, but that's expensive and hurts our perf, and it's too late to change it now.
Right. So it seems to me like this person wants to turn their read-only list into an iList.
But we could actually, so we could do read-only collection dot create for read-only list, and all that we have to do is in that have our own iList type that forwards to the read-only list members, and then it sets the read-only collection dot list to that. Like all we have to do is write a forwarder.
You could even do that.
I mean, that's not unreasonable, right? We could say we provide these wrappers in a centralized place. So we could say we have a, iCollection from an iRead-only collection. We have an iRead-only list from an iList, right? And then we can just say, yep, if whenever you have this mismatch, call this centralized API that gives you the wrapper for the other side. I mean, that wouldn't be bad. There's really no way around that, right? So, like, whatever you do, like, somebody has to pay for an interaction no matter what, unless we can unify these interfaces, which we don't seem to be able to do. But basically, if we do that, we wouldn't do this API either, right? We would just say there's a maybe we make them extension methods so they're more, I guess, as list on something that is IRead-only list. And if the instance already is a list, you just return that one, right? I mean, we could just define those methods as not, not doing double wrapping, basically.
Okay, so basically, yeah, I mean, you would still have then the interesting question of sometimes you see for each of the three things potential types and not just read-only collection, because there's also collection of T, which is a list of T and not a collection of T, because we're good at names. Talk or bring that issue forward.
Yeah. Because I mean, like, this one seems bad because I mean, the only way to fix the ambiguity is by either taking like IEnumerable, which seems weird, or having dedicated overloads for the existing concrete types like list and dictionary, which seems all bad because it's just noise. And this one would, like, this new